discussing all R belongs to the combinational circuit. And you know what is the properties of combinational circuit. Combinational circuit is always, output is always depend on the present input. Okay, there is no memory concept. Okay, yeah, if instead is in that particular instance of time, if input is changing, then it is automatically affect on the output. Okay, so the combination of present input is generated the output. Okay, so output is totally depend on the input at that particular time. Now we are discussing different type of circuits like adder, subtractor, parallel adder, and why we are not specifically using the subtractor, because what happened, we are using the complement from whose complement. So what happened, using the same circuit, we can parallelly we can complete the addition task also and subtraction task also. Though we are using, but you have to know that means how we can build the subtractor circuit and all those things. Okay, so today again we are discussing some particular part. Okay, so actually CLA means what, you know, carry look ahead adder, and till now we are discussing carry look ahead adder and ripple carry adder, you remember. Okay, and what is the advantage if we are using the carry look ahead adder as compared to the ripple carry adder? Because what happened, the less time delay is required when we are using the carry look ahead adder as compared to the what, ripple carry adder. Okay, now because what happened, the main objective the designer is that how we can optimize the circuit, and after that what happened, how we can propagation delay is less, or delay time delay is less. So different type of parameters are there. Based on that particular parameter, designer designed the circuit. So if we are one particular circuit is better, it is depend upon the different type of parameters. Okay, so see, today again I am discussing this particular part. So 16-bit adder. Okay, 16-bit adder using the 4-bit carry look ahead adder. Okay, so why I'm using second level, that particular part I'll discuss after a few seconds. Okay, now see here, you have already know that means how we are designing the 4-bit adder using the carry look ahead adder. So earlier class we have already discussed. Okay, now see here. So when we are talking about the CLA, you remember one particular part. One is called what? One is called a GI. GI means what? Carry is generated. One is called a PI. Carry is propagated. Okay, and one is called a SI. SI means sum. Okay, sum, because we are dealing with the carry look ahead adder. We are dealing with the adder. Okay, so what happened? This particular SI is coming. So when we are using the generate the carry, okay, generate the carry means what? You remember it is 2 delta. Okay, you remember this one is the 2 delta. Again, what happened? This one is called a propagated the carry is called a 3 delta. Okay, so why it is 2 delta? Because we are using only 2 level gate. So it is 2 delta, and PI it is related with the XOR gate. And when we are breaking the XOR gate, there are different type of things are coming, NOT gate, AND gate, OR gate. So it is 3 delta, level is 3, so it is 3 delta. And SI it is required 3 delta. Okay, so this particular part I think I have already discussed. So to tell what happened, it is required is 8 delta. Okay, but when we are going to the ripple carry adder, that time what happened, it is 9 delta instead of 8 delta. So based on the time delay, the carry look ahead adder is the better than the ripple carry adder. Now thing is that when we are using the 16-bit adder, we are talking about the 4-bit adder, it is okay. But what happened, when how we can designing the 16-bit adder? So if we are using 16-bit adder directly to related to the bits 0 to 15, that time what happened? That time what happened? That time what happened? It is very lengthy. Okay, the lengthy means what? That means we are computing more number of bits. Okay, so what happened? When we are using the 16-bit adder, we are using some particular 4 number of 4 bits adder we are using, because 4 into 4 is 16. Okay, so suppose here A is one type of sequence, B is another type of sequence, and when we are using the 4-bit adder, the B is range is 0 to B0 to B3, A0 to A3. Again, when we are going to the second 4-bit adder, it is B0 to 4, the B4 to B7, A4 to A7. So just I'm naming 47. 47 means what? B4 to B7. And suppose here some dash is, it is, I am not covering this one. Okay, suppose B8 to 11, B8 to B11, A8 to N11. So it is going up to 15. Okay, well, good. Now what happens, see here, if we are using the one level, that time what happens, time is more. One level means what? Whatever we are discussing the earlier. Again, what happened, carry is propagated, this particular, some particular carry is propagated here is carry is propagated, again here is carry is propagated, though we are using the carry look header. Because what happened earlier, what happened, we are discussing only the 4-bit header. So that particular time, what happened, no carry uh, propagation and rippling is there. Okay, but here we are using only the 16-bit error. When we are talking about the 16-bit error, that time what is the connection of this particular 4-bit error, this particular 4-bit error, no, error based on the carry. Okay, so if we are designing one level, that time what happen, again what happen, carry is propagated to the one error to the other error. And when carry is rippling, that time what happen, delay is occurred. Okay, so so again what happened, time delay is more, though we are using the carry look ahead error. Now what happened, can we minimize this one? So what happened here, yes, we are using the 4-bit adder here also, here we are using the 4-bit adder, here we are using the 4-bit adder, but we are don't use the carry propagation or carry rippling. Okay, and carry rippling, actually what happened, we are take care of the carry look ahead error. That means what happened, carry is generated parallelly. Remember, all the carries are generated in this particular rectangular box. That means what, carry is generated parallelly. Okay, to this, from this particular carry look ahead logic. So this particular one is carry, this particular, so what happened, all the carries C0, C1, C2, C3, all are parallelly computed. Okay, so here in this particular first point, I am using, when we are using the second level. Okay, so what happened, suppose what happened here, some particular gates are there again. So here 4-bit error is already there. So what happened, when we are using the second level carry look ahead mechanism to generate the input carries to the CLA blocks in parallel. This particular part is very important. So parallelly what happened, we are providing all the carries. Okay, and remember, when we are generating the carry, that means this particular rectangular box generate the carry in parallel fashion. So one, it is not like that at first it is C1 is generated, after that C2 is generated, after that after a few times C3 is generated. It is not like, parallelly means what, at a time, at a particular one shot, all the carries are generated. Okay, so what happened, some particular fixed time is required. And when we are discussing the 4-bit carry look ahead adder, you remember the generate function, carry generator, that means it is denoting by GI. It is required always 2 delta. Okay, it is always required 2 delta. So that means what? This particular portion, it is required, but it is required 2 delta. Okay, and this particular part means what? It is the generator and generating the sum is fixed. See, fixed means what? It is 8 delta. Okay, it is 8 delta. And when we are talking about the 4, instead of 16-bit adder, if we are using the 4-bit adder, that time what happened? This one is the 8 delta. Total time delay is 8 delta. But here what happened? Total time delay is 10 delta. 8 plus 2 means what? It is 10 delta. Are you getting it? This one is 8 plus 2. So we are getting the 10 delta. So if we are when we are using the second level carry look ahead adder, that time always remember this particular C1, C2, C4. Sorry, here I am not using C4. You can use here. Okay, C1, C2, because this one is the initial carry. C0 is the initial carry. So C1, C2, C3 and C4 in parallel with 2 delta. 2 delta means what? Only we are using the 2 level gates. So it is time delay is 2 delta. Okay. So if you are going to the n bit adder, that time what happen? It is this particular, if number of bits are more, that time what happen? We are adding the more number of levels. Okay. Suppose what happen if we are using the 4 delta, that time what happen? We are getting the 8 delta. And if we are using the carry look ahead adder, CLA means what? Carry look ahead adder. And T means
Excuse me, sir.
Yes.
S20 is trying to join from 9-5 something.
Pardon?
S20 is trying to join from quite a while.
Okay, just a minute. Just a minute. No one is. I am not. That means no one is. Please try to join. Please call them to join.
Yes, I'm telling them.
Why it is 9 a.m. Then why they are not earlier? Why they are attempting after 9?
So he was trying after 95. Since 95, sorry, sir.
Screen is visible?
Yes, sir.
Okay. Just a minute. Okay. Any other?
No, sir, only one story.
Okay. See here. So n means what? It is the number of bits. And TCLA means what? Time is required if we are using the carry look ahead adder. And TRCA means what? Time delay is required if we are using the ripple carry adder. Okay. So you know 2 delta plus 3 delta plus 5 delta equal to 8 delta if we are using the CLA. And if you are using the RCA, you know this one is the formula. The first part when we are discussing earlier, that time see here this one 2n plus 1. That means what? 2 into 4, if we are using 4 bit, 8 plus 1 is 9 delta. So here it is 9 delta. Now see, when we are comparing, always what happens, the carry look ahead adder gives the better performance as compared to the ripple carry adder. Okay, and this is the formula. That means why 6, because what happens, why we are using the 6 means what? Always what about if we are starting from, because generally people are not using 2-bit carry adder. People are starting from the 4-bit carry adder, because 2-bit carry adder it is very simple. So what happens? So when we are using the 4-bit carry adder, that time what happens? C1, C2, C3 is fixed. Okay, and whatever you can use the 16-bit carry adder, 32, always C1, C2, C3 is fixed. So when we are using C1, C2 to always what happen? It is generated, the carry is generated 2 plus 2 plus 4. So this one is 4. No, sorry, this one is 6. 2 plus 2 plus 2. So this one is 6. And log 4n means what? It is the power of 2. Okay, it is multiplied with 2. So if you are carefully check and apply this particular formula, then you are getting this one. Meaning is that, suppose what happened till now, here we are using the 16-bit adder. So I am already, that means if we are using the 2 level, that time what happened? The time delay is 10 delta. So here it is coming 10 delta. Are you getting my point? So 10 delta means what? 2 delta is fixed for carry generator, and earlier it is 8 delta, because we are using the 4-bit. 8 plus 2 means what? It is 10 delta. Again what happened? We are adding 2, then this one is 12. Again what happened? See, this way actually, this one, this 4 into 4 means what? 16. 16 into, that means we can multiply doubles. 16 into 16 means what? It is 16 into 2 means 16 power of 2 means what? This one is 64. 64 power of 2 means what? This one is 256. Okay, this one is what? 256. So what happen if 4 bit is 8 delta? This one is the 8 delta. We can adding with the extra parallel computation. So of carry. So carry means what? It is, you know, it is required only 2 delta. So 8 plus delta means what? It is 10 delta. 8 plus 2 means 10 delta. 10 delta plus 2 means what? It is 12 delta. Yes or no? It is 12 delta. And 12 plus 2 means what? It is 14 delta. So important part is that in between 16 and 64, 32. This one is 32. And also it is lies in the 12 delta. Are you getting my point? And when we are using the 64 to 256 here, 128 is already there. So it is also, it is required 14 delta. But when we are comparing with the ripple carry error, that time what happen if we are applying this particular formula, that means see here the time delay is more. Okay, because see here, if we are using the 128 bit, it is required 14 delta, but if we are using the ripple carry error, then it is 257 delta. Okay, any doubt this one? Are you getting, all of you getting? Any doubt, then please ask me.
No, sir. No, sir.
No, sir.
So this one, this way, this particular formula you remember, this way we can finding the n bit error. And people are asking, that means what is the advantage CLA as compared to the RCA? Okay, and you clearly know what is the difference between the CLA and RCA. Okay. Next, see here. Earlier we are the last class we are discussing about the full subsector. I think the half subsector. You remember this particular circuit generally, because no need, because we are using the, if we are using the parallel error and subsector, that time when we can successfully complete the subsector also. But you have to know this is also important, and this one is called a borrow propagate subsector. And earlier what happened, we are this particular borrow propagate subsector means what? It is similar to the ripple carry error. Okay, so what happened here, why we are using D? D means what? Difference. And B means what? It is borrow, because we are using the subsector. Earlier what happened, it is called D is when we are using the error, instead of D1 we are using the S1. S means what? Sum. And here instead of B we are using the carry. Same logic we are applying, but we can fulfill the properties of subsector, because subsector is what? It is generated borrow and difference. And it is D. D means what? Difference, and B means borrow. So see here, again, this particular borrow is generated from this particular first subsector to the second subsector. Again, what when borrow is generated from this to this, something like that. And after that, what when if borrow is generated, final, this one is the B5 is the final borrow generator. And how many bits we are using? We are using 4 bits, A1 to A4. If we are starting from, instead of A1, if it is starting from A0, that time what happen? It is A3. Okay, and then automatically what happen? This one is also B0 and this one is B3. So I am writing this way: A1, B1, A2, B3. So see here, the same formula we are applying also this particular borrow propagate subsector. Whatever we are using the ripple carry error. Okay, so what happen if we are using the 16-bit error? The earlier we have seen that in 16-bit error it is required 33 when we are talking about the error. Okay, and when it is, and how it is 33 is coming when we are using the ripple carry error. Same thing we are applying in the borrow propagate subsector. Also it is, we are getting the 33 delta, because all the properties are same in this particular circuit. Instead of B3, if we are using the error, then this one is C3. Okay, something like that. So if someone is asking, then time delay of borrow propagate subsector and ripple carry error are same, because what happen, we can fulfill all the circuit properties are same. Okay. So obviously then if we are comparing this particular borrow propagate subsector to the ripple carry error, that time what happen? Also time delay is more. So how we can minimize the time delay? Okay. So this one is called again, earlier what happened, carry look ahead error, now it is called a borrow look ahead subsector. And we are using the same properties. Whatever we are using the carry look ahead error, the same properties we are using. Okay, just see, remember, D means what? It is difference. And B means what? Here, borrow. And this one we are generating the borrow generator bit. Suppose we are especially giving the, because otherwise when it is conflict with B, so I am using the beta I. Okay, so difference means C. Just a minute. Now see here, difference means what? How we are using the difference. So you remember one particular diagram is there. So this one we are using as a, suppose AI. Okay, suppose this one is AI, this one is BI, and suppose this one is, we are using beta I. And what happened here? Here is, suppose DI is generated. D means difference, and some particular beta I plus 1. Okay. Now see, you remember when we are using 0, okay, 0 minus 1, that time what happened? The borrow is generated. That means we can borrow borrow from somewhere. Okay. So that time what happened? This one is the generate the borrow. Are you getting my point? So GI, see here, GI, if we are writing in the sub form, AI complement means what? This one is 0 and this one is 1. So if this particular condition is satisfied, that time what happens? GI means what? Borrow is generated. And PI means what? PI means either which particular condition, if we are breaking this one, that means AI XOR BI means what? AI complement with BI plus AI BI complement. So either this one is 0 or this one is 1, or either this one is 1 and this one is 0. So here I am writing AI XOR with BI. We are writing the AI XOR with the BI. Are you getting my point? So what happened here? How difference is generated for ith bit? So it is PI. PI means what? This one, AI XOR BI, and beta I means what? Beta AI is already present. This one. So this one means what? If we are properly check this one, DI means this particular D and DI is same. So PI is, this particular PI portion is coming here, and BI is already present here. Are getting my point? And BI plus 1, that means GI means what? GI, see here, GI is what? AI complement BI. So I already told you the how we are getting AI complement BI. So this particular GI is coming here. Okay. And BI is already present. This particular BI is already present here. And PI dash means what? PI dash means PI means what? This one is AI XOR BI, and after that what happened? We are giving the complement. And if we are writing this way, that time what happened? It is denoting as A X NOR B. Are you getting my point? So here I am using PI complement. And why we are using propagate? Propagate means what? What is the formula of AI XOR BI whole complement? Either this one is AI with BI, okay, propagate. That means, remember, not a carry propagate. Now this one dealing with the subtractor, so borrow propagate. So what happened? AI complement, BI complement. If you are breaking this one, earlier I am just we have seen how we are breaking this one. So it is the this way also, this equivalent to this. So that means what? This one is either 0 0 and this one is either 1 1. Okay. So this way what happened? The borrow is what? Borrow is not a generated, borrow is propagated. So here I am writing beta I plus 1 GI plus PI BI. And if you are breaking this particular hold the statement. Suppose if we are I am going, suppose B0 is the input carry, and what is the formula of B1? B1 formula is, now what happened, it is I plus 1, so this one is Gi. If it is I plus 1, that means what happened, this is 1 and this one is 0. That means previous level 0, G0 plus P0 dash B0. So G0 means what? G0 means what? A0 complement B0, A0 complement B0, and P0 means what? A0 XOR B0. That means we can write this way also. Okay, and after that what happened? This one is the beta I means what? Now it is B0. So this particular beta I represent the B0. And after that, when we are going to B2, that means what? B1 is already we are getting from this one. Okay, just we can put this one, and this way we can continue. If we are using 4-bit, then what happened? B0, B1, B2, and B3. Are you getting my point? So this way we can just a minute. There's something I am missing or what? B0. Yes, correct. If we are using the 4-bit, that means what? B0, B1, B2, B3. If you are using 5-bit, B0, B1, B2, B3, B4. This way we are continuing. Okay. And based on this particular expression, we can design this particular. You can carefully check this particular diagram, and you can automatically, it is similar to the carry look ahead adder. But what when based on the expression, this particular expression is something different. Okay, as compared to the carry look ahead adder. But other parts are same. Oh, sorry, this one is the not gate. So I am denoting this one is the not gate. This one is the... Any doubt this one?
No, sir. No, sir.
Okay. So what happened now? What happened? Time delays. We are getting same. Okay. And don't worry. And your lab class will be started very soon. Most probably after 2 and 3 days, your lab class will be started. Okay. So all of you know the Jagannath sir, the number of the Jagannath sir.
No, sir. We don't know it, sir.
Okay. So, okay, no problem. We will provide one particular, class time. And according to the class timetable, we will start our lab. Okay. And also, I'm the first, second lab also I will present. Okay, no problem. And he will demonstrate which particular tool or which particular language you are using. Okay, so whatever I am discussing, you just all are implement some particular hardware language. Suppose one is called a Verilog. Verilog is a one type of standard hardware language, and one is called a VSDL, a very high definition language. So whatever you are getting till now from my class, you can implement. So preliminarily, we will demonstrate how we can implement the AND gate, how we can implement the XOR gate, NOT gate, whatever. And after that, you can design the decoder, encoder, whatever. Some particular problems are coming, then how you can implement. Okay, based on that particular hardware language. Okay, and when we are designing the hardware language, that time what happen, one particular portion is their timing diagram, how circuit is behave, and then how if you are providing some particular input, then how outputs are generated, and what is the time delay. If the circuit is 3 level, then what is the time delay to the, so you are getting all of those things. Then also it is if your this particular concept is clear, then you can easily understand. Okay, just you can know how to write the programming and all those things because you already know C and C++, whatever. So it is not a very complex for you. Okay. Now directly we are going to the decoder. So you many times you heard about yes please do the decoding the code. Decoding the code means what? Or encoding the code. So actually what happens really, if you are going to the physical properties or physical level, this type of things are coming. Okay, and till now whatever you are getting, all those things are theoretical type. Okay, so actually machines do this way. Decoder means what? Actually machine doing this way. See here, decoder also one type of combinational circuit, because whatever outputs always depend on the present input. Here I am giving some particular small definition. Binary codes are used to represent discrete quantities of information. Okay, from the binary codes, we can represent any discrete quantities of information. Okay, and this particular decoder also we are using some particular code conversion, data distribution, or suppose some particular functional block of memories. So different type of application we are using the decoder. So at first, what is decoder? A binary code of n bits is capable of representing up to 2 to the power n discrete elements of the code information. Okay, that is the general observation from the digital circuit. Now, based on that, designer thinking that why we are not applying this one. If we are applying n bits and if we are capable to represent the 2 to the power n discrete elements of the code information, that why we are not designing that type of circuit or this type of circuit. Okay. So what is the properties of decoder? See here, first point. This point, it has n inputs and 2 to the power n outputs. Always remember, typically decoder has n inputs and 2 to the power n outputs. Okay. Next point, depending on the applied input, exactly one of the output line is set to 1, while all other lines are set to 0. But this one is not mandatory. Remember, this one is not mandatory, but by default, people are using this particular concept. What is the concept? If those lines are active, we are detecting only one line is active. Okay, out of that. So when one line is active, we are denoting as a 1, and all the deactive line we are denoting as a 0. By default, people are using this particular concept, or designer are using this particular concept. But you can use reverse convention also. In some decoder, what happens, just we are the selected output line we are set as a 0, and when all the deactive line we are set to 1. Okay, but some particular special decoder we are using this one. Okay, that time what happened, some particular the different type of gates we are using, suppose we are using some particular NAND gate or NOT gate, or because what happened, just we are reverse this particular concept. Okay, so this one is the application of decoder. So different type of applications we are using. Just I am giving some particular example, selecting one out of many functional blocks, decoding. Okay, and generally memory is a vast element. So that time whatever we are um, um, we are connecting with some particular functional block of memory, that time whatever we are using decoder. And many applications we are using the decoder, suppose code conversion, data distribution, cryptography, network security. There are different type of applications are there. There with the help of decoder. Okay. See here. Here I am using 2 to 4 decoder. So what is the A? That means what? It is n inputs and 2 to the power n outputs. So what is the input? Input is n, and 2 to the power n means what? 2 to the power, here we are using only 2 line. 2 to the power square means what? It is 4. So what happened here? 4 outputs are generated. This one is the outputs, and this one is the inputs. And what is the template we are using? N. This one is n, and 2 here n equal to 2 and 2 to the power n equal to 4. So this way we can write 2 to the power 4, 3 to the power 8, something like that. Okay. This is the block diagram. Now see here, what is the behavior of this particular decoder. So here we are using, this one is the input, this A0 to A1 is input, and Y3 to Y0. Suppose we can read this way, Y0, Y1, Y2, Y3. Okay, this way. This one is the output. but out of 4 output, only 1 output is active. If it is 0, 0, the combination of A0, A1 is 0, 0. That time what happen? Y3 is active. If A0, A1 is the binary sequence is 0, 1, that time what happen? Y2 is active. Okay. If binary sequence of A0, A1 is 1, 0, that time what happen? Y1 is active. Okay. And when A0, A1, the binary sequence of A0, A1 is 1, 1, that time what happen? Y0 is active. Okay. And if we are writing in the expression format, that time what happens? See here, y3 is 1. What is the value of a0 a1? It is a0 complement a1 complement. We are writing in the soft form. y2 means what? This one is 0 and this one is 1. So it is, I am writing a0 complement a1. y3 is something like that. It is similar. Okay. So this way we can design the decoder. Any doubt? Up to this, any doubt?
No, sir. No, sir.
No, sir.
Okay. Very good. Now see here, before we are going to this particular example, I'm just discussing something. This is the normal decoder. Yes, no problem. But some particular situation, we are using one particular extra line, and generally what happen? Generally we can prefer this particular line. We are this particular line we are using here, and this particular line is only one particular line. No. Some particular cases are there, but I don't know. Generally, we are using standard is only one particular line we are using. And this particular line is called a enable input or enable line. Enable, E-N-A-B-L-E, enable line. And why this particular line is necessary and why this particular line is required? Because you know normal inputs are there and outputs are there, but this particular line is called a enable input or enable line. When we are implementing one particular decoder with the many decoders, or some particular situation what happen, we are using many decoders, suppose 1 decoder, 2 decoder, 3 decoder, many type of 2 to 4 decoder. This is only one decoder. Okay, so suppose we are using the 3 decoder. That particular situation, if we are active only one decoder, that time what happen, this particular enable line is required. Enable means what? It is controlling which particular time which particular decoder is active, and at that time all other decoders are deactive. That particular part is controlling by this particular enable line. Are you getting my point? So suppose we are taking some particular example. Suppose, okay, see here how actually this particular enable line actually working. Okay, so example is that design a 2 to 4 decoder including an enable input. Suppose this is the question, suppose example. Okay, how we can design the decoder. So you know 2 to 4 decoder, how we are writing. This is the block diagram of 2 to 4 decoder. Okay, after that question is mentioning that we are putting as a enable input. So here we are using one particular enable input. Now what is the behavior of this particular circuit? Remember, when we are constructing any behavior of that particular circuit, always it is represented by the truth table. Okay, so here I'm using A0, sorry, E is the enable input, this one, and A0, A1 is the input, and all other Y3 to Y0 are the output. Okay, see here, up to this one, decoder is working. That means what? If E0 value is 0, that time what happens? Decoder is working. Are you getting my point? That means suppose here we are using this 0, 0 means what? This one we are using active low. That means what? This one is the active low, suppose. And here we are using some particular NOT gate. When it is 1, that time what happens? It is always 0. When it is 0, then it is 1. Okay, 1 means what? Deactive. This, so what happens here? when value equal to 0, that time what happen, decoder is working. And when the value equal to 1, that time what happen, whatever the value of A0, A1, it is does not matter. Always what happen, all the outputs lines are deactive. So for that particular purpose, because up to this one, decoder is active. So here I am using extra input line E bar, E bar, E bar, and E bar. Okay, and it is not like that you can always using here 0 also. You can use here 1 also, and so then the whatever some particular circuit diagram, instead of we are not using any NOT gate or something like that, directly we can use this one. Okay, so it is the representation. Okay, are you getting this one? Any doubt? Any doubt?
No, sir. No, sir.
Now, this is the one example. Constructing 4 to 16 decoder using 2 to 4 decoders. Here remember, I am using S decoders, but our main objective is that construct the 4 to 16 decoder with the help of 2 to 4 decoders. Okay, so always remember, when this type of question you have encountered that time always remember which type of decoder we are going to construct. Now, what is the main decoder? Here in this particular question, main decoder is 4 to 16. But we are using, when we are constructing 4 to 16, that time when we are using 2 to 4 decoders. Okay, that means what? When we are constructing the 4 to 16 decoder, based on the decoder properties, inputs are D0 to D3, D0, D1, D2, D3. And what is the output? Outputs are generated because this one is the 16, 0 to 15 means what? This one, this particular outputs are generated. Okay, for decoder to generate the 16 output, obviously, because 2 to the power 4 means what? It is 16. So 16 outputs are generated. Sorry, here I am using D0, so don't confuse. Here you can use the F0 also, no problem. F0, F1. So how many outputs lines are there? How many output lines are there? 0 to D0 to D15. Okay, and but remember, you cannot use the 4 inputs, because if you are using the 4 inputs, that time what happen? Yes, this particular property is satisfied, but this particular property is not satisfied because we are using only 2 input. Because example is clearly mentioned that using 2 to 4 decoders. So to construct the 4 to 16 decoder, how many 2 to 4 decoders are required? 5 decoders are required. This one, this one, this one, this. How many decoders are required? 2 to 4? 5. And why it is 5 and how this particular circuit is working, I will explain. See here, because all are the 2 to 4 decoder, so what happen? We can use only 2 inputs lines. And 2 to 4 decoder means what? Output always 4 input lines are there. This one is 1, this one is 2, this one is 3, and this one is 4. And see, all the decoders have a 4 input lines. This one is the 4 input lines. This one is the 4 input lines. Okay. So this is the properties of 2 to 4 decoder. Now see here, because our actual aim is that to construct the 4 to 16 decoder. So if we are using here 4 decoders, that time what happen? This particular condition is fulfilled, D0 to D15. D0 to D15. If we are using the 4 decoder. If you are using the 4 decoder, then we are getting the output D0 to D15. Then what is the meaning of this one, the another decoder, this particular decoder? Why we are using the 5 decoder? Excuse me. Huh? Hello? Hello? कहाँ से? ओ हाँ बोलिए 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 बोलिए। नहीं नहीं, मैं एक्चुअली बाहर में था पूजा में, ठीक है, मैं आया नहीं था एक्चुअली। मैं थोड़ा अभी मैं कल परसों पहुंचा हूँ, मैं आऊंगा आपके पास। हाँ, मैं आ रहा हूँ, ठीक है। So now what happened, this particular decoder, see why we are using the 5 decoder instead of 4 decoder. Okay, so here what happened, if you are using 4 outputs, suppose what happened, suppose I'm using, suppose D0, suppose here D0. Suppose what happened here, D0 is 0, suppose D1 is 0, D2 is 0, and D3 is 0. Then which particular decoder actually we are selecting? So see here, if A and B is 0, 0, A and B is 0, 0, that time what happened? This particular D0 line is active. Okay, and this particular D0 connect to the enable input. That means what? This particular decoder is active. Okay, and suppose here you can use this way also. Don't use the DC. Suppose ABCD. You can use the ABCD. It is better. Don't use it is cut this way. ABCD. That time what happened? See here. AB when it is 0, 0, that time what happened? 1, 2, 3 line is deactive, and this particular 0 is connected. That means we are, when AB is 0, 0, that time what happened? D0 line is active. Are you getting my point? This one is the D0 line, this one is the D1 line, this one is the D2 line, this one is the D3 line. So D0 is connected to the which particular decoder? This particular decoder. This one. Now what happened here? CD equal to 0, 0, because based on this here CD also 0 and D also 0. Then which particular line is selected? D0 line is selected. So D0 is already selected. Suppose what happened if we are using 1, 0, 1, 0, 1, 1. So 1, 0 means what? This one is the 0, 0. Yes, 0, 0. That means what? This one is the D0, D1 line is active because AB is 1, 0. Yes or no? So we can write this way also. If we are using the 2 bits, that time what happened? This one is 0, this one is 0, this one is 1, this one is 0, this one is 1. Okay, this one is 0, 0, this one is 1, 1, and this one is 1. So which particular line? If it is 1, 0, that time what happened? Number 2, D2 line is active. This particular line is active. And after that what happened? This particular line connecting to this particular decoder. Okay, that means what? This decoder is active. Decoder number 3 is active. And out of 4 input lines, which particular line is active? 1, 1. 1, 1 means what? 0, 1, 2, 3. D11 is active. So here D11 is active. So this way we can suppose what happened, instead of suppose here 1, 1. 1, 1. Suppose 1, 0. So 1, 1 means what? Last one, this one. So D3 is active. This particular, D3 line is connected to enable line, this one. So fourth number, this is decoder is active when we are considering the parallel decoder. All the this particular diagram, this portion of the diagram. Okay. So last decoder is active, and 1, 0 means what? This particular line number D13 is active. So are you getting this one? Any doubt this particular diagram? Any doubt?
No, sir. No, sir.
No, sir.
So this way you can construct different type of decoders with the help of other decoders. Okay, so your concept must be cleared. Okay, so this way we can design, or maybe it is, suppose you can design to 8 into 32 decoder, something like that, with the help of different type of decoders. So many type of examples, solved and unsolved problems are there. You can just check the your standard or your normal textbook. Okay. Now what happen? How we can realizing the logic function using decoder? How actually we are using decoder? Suppose there are some particular functions are there. With the help of this particular function, you can design the decoder with the help of and external gates. Because this is the function, some particular gates are required, and main basic target is that we can design the decoder. Okay. So can you know what is the solution of this one? How we can solve this one? At first, what we will do? हम लोग को पहले क्या करना पड़ेगा? Any idea?
सर इसको पहले सिंप्लीफाई का फॉर्म में ले जाना पड़ेगा.
कौन सा सिंप्लीफाई का कौन सा फॉर्म में लेकर जाना पड़ेगा?
सबसे छोटा वाला.
ओके, सिंप्लीफाई आप करेंगे, उसके बाद क्या करना पड़ेगा? क्या फॉर्म में लेकर जाना पड़ेगा? एक्सप्रेशन फॉर्म में और समथिंग डिफरेंट? See, decoder means what? We are dealing with some particular numbers. Okay, this one all are 0, 1, 2, 3. Here it is 0, 1. Here it is 0, 1, 0, 0. Something like that. Some particular, all the lines are connected with some particular binary sequence. Okay, so binary numbers, and when we are combining all the lines, then it is creating the binary sequence. So obviously what when we are when we are evaluating or when we are realizing this particular function, that time what we are converting to the min terms from or max term forms. Okay, so generally max term is just opposite. So generally what we are using the min terms form. So how many variables we are using here? We are using the 3 variables x, y, z. Are you getting my point? So what here x, y is there in the, if we are going to the first function f1, that time what z is missing. But in this second term, all the variables are present. But when we are going to the second function f2, that time what the first term yz is missing and second term xz is missing. So you know from the function how we can find the mean terms. So I'm giving the example. You can try at your home. So what just I'm not writing the expression and all those things. You can now you can put the x bar, y bar within bracket z plus z bar, and after that break it, and based on this you can find the mean terms. So f1, suppose we are getting here sigma m, because this one we are converting to the mean terms from. So we are getting 017. आप लोग ट्राई कीजिएगा घर में कैसे 017 मिला, ठीक है? मैं इस चीज को बार-बार नहीं समझाऊंगा. Thus I am directly put this one. F2 we are getting F2 में मुझे क्या मिला? 0 मिला, yes, 1 मिला, 2 मिला, after that 3, 6, and this one is 7. And F3 में मुझे क्या मिला? That means how we are getting this one when we are breaking this particular expression. Okay, so F3 means what? F3 we are getting the mean terms summation. This is the symbol of min terms. Summation is small letter m. And this one is what? 0, 1, 0, 1, 6, 7. Now what happens when we are getting the min terms? This one is the min term, this one is the min term. Now we can design the decoder. Okay, how we can design the decoder? So how many variables we are using? We are using 3 variables. And how many outputs? What is the range of the outputs? 7, up to 7. Then obviously what happens? We are using the what type of decoder we are using? Can you tell me? Based on the function, we know that we are using only the 3 variables. So input is 3. Then now what is the output?
8.
Yes, correct. कितना टाइम लग रहा है? 3 into 8 decoder. बाकी तो सो रहा है, मुझे पता है अभी. See, it is your duty, भाई. Just I am discussing all the topics very carefully. आप वहां पे सो रहे हैं, देख रहे हैं, उठ रहे हैं, क्या कर रहे हैं मुझे पता नहीं. ऑन करके कहीं पे चला गया, then also I don't know. But what happened? This particular all the subjects it is related only with you, not with me. एग्जाम कौन देगा? मैं नहीं दूंगा, आप लोग देंगे. मार्क्स किसको मिलेगा? आप लोग को मिलेगा. नॉलेज किसको गेन होगा? आप लोग को गेन होगा. सो वो पूरा बिजनेस आप लोग के ऊपर है. वहां पे कोई लड़का जस्ट एडमिट किया और वहां पे प्रेजेंट नहीं है और बोल रहे हैं कि बाद में किसी से सीख कर बा कोई मतलब लेक्चर देखकर सीख लूंगा. Okay, that is something different. If you are managing, then it is okay, good. But day-to-day work or tasks you have not completed, then what happens? Your concept is not clear. So it is up to you now. You are a 3rd semester student. You well mature. If you are carefully listening all the class, then it is very well. If you have no doubt, then also very well. If you are something wrong with you, then it is very difficult. It is not my problem. It is your problem. Okay. So 3 into 8. So what happened here? I am using suppose I am giving because function it is mentioning XYZ. So here I am using XYZ. And how many outputs are there? Because based on the min terms we are getting, the maximum number is highest number is 7. So obviously it is output is 8. So 0, 1, 2, 3, 4. Okay. Now see here. Now F1 is connected. What is the min terms of F1? 0, 1, 7. So I am directly connecting. This one is 0, 1. This one is 1. And this one is 7. Okay. And what is the min term of F2? 0, 1, 2, 3, 6, 7. So this one is 0. 0, 1. This one is 1. Two. This one is 2. Just you can check this one. 2, 3. So this one is 3. 3, 6, 7. This one is 6. You can just suppose just carefully check, because this one is 7 and this one is 7. And F3 is 0, 1. So this one is 0. Already this one is 0. So I am enlarging this one. This one is 0. 1. This one is 1 again. Okay. 1. And this one is 7. So this way we can construct the decoder. Any doubt this one?
No, sir.
Any doubt?
No, sir.
ओके जो जिसने अभी नो बोला उसका नाम बोलिए बोलिए बी ऑनेस्ट किसने कोई भी प्रॉब्लम नहीं है बोला अच्छा बात है आपको आपको कोई सब
Yes,
डाउट
sir.
क्लियर है आपका नाम बोलिए
मनीष कुमार सर.
मनीष कुमार आपको समझ में आ रहा है ये
जी सर. F1 represent 017 and F2 012367 and F3 0167.
ओके मतलब आपको समझ में आ रहा है ना
Yes sir.
ओके वेरी गुड नीरज आपका नाम नीरज बोला ना आपने
नहीं सर, मनीष.
मनीष ये बोलिए why you are using NAND gate here
Yes sir.
why we are using NAND gate here मैं क्यों एक्सटर्नल गेट तो बोला था कोई तो स्पेसिफिकली NAND गेट नहीं बोला था क्वेश्चन में ठीक है इसमें मैंने क्यों NAND गेट यूज किया जो एग्जांपल है क्वेश्चन है इसमें बोला था एक्सटर्नल गेट्स इसमें मैंने क्यों NAND गेट यूज सिर्फ NAND गेट क्यों यूज किया AND गेट क्यों यूज नहीं किया NOR गेट क्यों यूज नहीं किया आपने तो बोला था अभी समझ में आ रहा है वो बोलिए मुझे कोई प्रॉब्लम नहीं है
नहीं सर, आपने अभी जो सर रिप्रेजेंट किया सर, अभी सर मैंने सर अभी अटेंड किया F1 एंड F2 F3.
ओके
सर,
ओके
आपने-
ठीक है अभी आपने अटेंड किया लेकिन अभी तो मैंने आपको तो एडमिट नहीं किया मैंने बहुत 9 बजे के पहले
एडमिट सर मैं पहले था, अभी एक्चुअली खाना खाने चला गया था, सो इसलिए दवा भी खाना था. मतलब सर अभी दवा खाना इसलिए मैं चला गया था.
तो अच्छा ऑनलाइन क्लास में मतलब आपको क्या होता है आपको ये भी फ्री मिल रहा है बीच बीच में आप उठकर जा सकते हैं ठीक है
नहीं सर,
अगर यही अगर आपने क्लास में करते फिजिकली प्रेजेंट रहता क्लास में आपको तो 1 घंटा 2 घंटा उठने के लिए नहीं मिलता
ये सर, इसके लिए सर
सॉरी का कोई बात नहीं है लेकिन बीच में मिस मत कीजिएगा ठीक है अगर खाना है तो सब टेबल में ही लेकर उठ के मत जाइएगा टेबल में ही सब कुछ काम कीजिए ठीक है पहले
ओके सर. थैंक यू सर.
अच्छा एनीवन कैन टेल मी व्हाई वी आर यूजिंग द NAND गेट्स इन दिस पर्टिकुलर सर्किट एनीवन
सर उसको फंडामेंटल लॉजिक गेट बोल सकते हैं ना उसको सब एंड और नॉट को रिप्लेस करके एंड गेट से हम वो लिख सकते हैं पूरा फंक्शन को इसलिए
Okay, it is very good answer. Yes, because NAND gate is the universal gate, so we can convert NAND gate. We can easily convert to the basic gates. Basic gates means what? AND or NOT. Yes or no? Yes or no?
यस सर
Okay.
यस सर
Suppose I am asking you one question. Instead of NAND gate, can we use another gate? NOR gate से भी हम लोग कर सकते हैं. NOR gate also universal gate. Yes or no?
यस सर यस सर
Correct. So what happen? You can use NAND gate. It is no problem. It is NOR gate also no problem. But what happen? This is just block diagram. So block diagram you have a no problem. But you can, if we are going to the circuit level design, that time what happen? You can, if you are using the NAND gate, then you can write the properly expression. What the expression is coming. If you are using the NOR gate, then also you can write the expression. What is the expression? This is because this one is the block diagram. Okay. So what happen? You can at first what happen? You can, if some particular question is mentioning that please draw the logic diagram, then what you will do? You draw this particular diagram, block diagram. You can find out the mean terms. Yes, it is fine. After that, what happen? You can draw the truth table. Okay, and after the truth table, you can easily design the logic circuit. Okay, how we can break the expression if we are using the NAND gate, how we can break the expression using the NOR gate. Okay, so when we are using one particular important things, you remember when we are using NAND gate, NOR gate, you always remember at least De Morgan's theorem must be applied. Then we can convert any particular, and we can convert basic gates also. We can convert some other gates also. Please write down this particular homework, all the homeworks. Homework 1, design a BCD to 7 segment decoder. You know the concept of decoder. Now you can try at your home. Okay. Homework 1, and I'm asking anyone. Next class, I'm asking anyone. So please be prepared today itself. ऐसा नहीं है कि सर टाइम नहीं मिला कहीं चला गया. आज ये क्लास खत्म होने के बाद बाकी जो क्लास है, आज मुझे नहीं लगता है सब क्लास आप लोग का होगा. 12 बजे के बाद ही आप लोग का शायद क्लास कंप्लीट हो जाएगा, 1:30 बजे के बाद. ठीक है, ऐसे में हो भी सकता है, बट आपको सेकेंड हाफ में भी टाइम मिलेगा. एटलीस्ट इसमें से पूरा कंप्लीट नहीं कर पाए तो 50% कंप्लीट कीजिएगा. So what is the first homework 1? Design a BCD to 7 segment decoder. Now what is 7 segment? 7 segment means what? You know the digital clock, na? So digital clock means what? If we are denoting this way, we can represent any digital number up to 0 to 9. Okay. If you are writing 0 that time, what happens? This one is, we can delete this one. Sorry, we can delete this one. Okay, then it is 0. If you are writing 7 that time, what happens? This one we are deleting. Okay, so what happens? So when we are deleting, that means what? It is deactive, it is 0. It is 0. It is 0, something like that. And those lines are active, that means what? It is 1. So for this particular case, we are using the decoder. So you know the concept of decoder. Now BCD means what? It is 0 to 9. You know already BCD means what? It is 0 to 9. So how we can convert BCD to 7 segment decoder or 7 segment display decoder? Okay, that is the homework 1. Homework 2, design a BCD to decimal decoder. Decimal decoder means what? 0 to 9 again. Decimal, that means what? We can write the 0 to how many numbers? If you are counting 0 to 9, 10. So how we are designing the BCD to decimal decoder? This is the homework 2. Homework 3, design a 2 to 4 line decoder with only NAND gates. Include an enable input. Whatever we are discussing till now. Oh, this particular is repeated now, so no need to this one. At least 2 you will complete. You have to do. Okay. सब बैठा हुआ है. Okay.
Sir, yes, sir.
Yes, sir.
Now, decoder part is complete. And again, if you are getting any doubt, then okay, obviously we'll discuss. Okay. Now, next one particular combination circuit, it is called an encoder. Encoder is it is the reverse of the decoder, reverse direction of the decoder. Okay. So encoder is a digital function, or you can say that a encoder is a combination circuit, okay, that produce a reverse direction from that of a decoder. Encoder typically has what? 2 to the power n inputs and n outputs lines. But decoder, what happens? It is n input lines and 2 to the power n output lines. So it is called a reverse direction. So when we are talking about the encoder, always input lines, 2 to the power n input lines and n output lines only. Only one of the input line is at a time. That means what? Only one input line at a time. So out of this one, only one input line must be active at a time. That means we are providing only one input line, not an active, sorry. We are providing only one input line out of those lines. Okay. The output will contain the binary code of the input line, that is one. So the output are generated, that means which particular lines are active, how many lines are active based on the combination of that particular input line, the outputs are generated. Okay. Suppose what happened, this is the structure of 8 to 3 into decoder. So 8 means what? It is 2 to the power n, and this one 3 means what? It is n. So how many inputs lines? Oh, so how many input lines are there? 1, 2, 3, 4, 5, 6, 7, 8. D0 to D7. Okay, and output line means what? I'm writing F0, F1, F2. This one is called data inputs. Also, some particular books it is called data inputs, or you can say the normal inputs of the encoder, and this one is called data outputs. Okay, so this is the diagram of 8 to 3 encoder, not a decoder, it is encoder. See, here we are using the behavior of this particular circuit, 8 to 3 encoder. So here I am writing the input lines D7 to D0. Okay, and output lines we are providing F2, F2, F1, F0. F2, F1, F0. Now see here, I'm active. We are going some particular systematic manner. Suppose D1 is active at first. The input line D0 is active at first. So it is 1. And all other lines are 0. That time what is the combination of the output? Output combination is F2, F1, F0, all are 0. When D1 is active, that time, and this particular line is deactive and all other lines are deactive, input lines. That time what happened? F1 is active. The output is F0. If this particular sequence are generated from the input line. Next what happened? This one is 1 and all other lines are deactive. Post or pre lines are all are deactive. That time what happened? F1 is active. This way we are going on. This one, this one, this one. We can say diagrammatically. This particular fashion is diagrammatic. Okay. Now see here, when F2 lines are active, that means F2 is generated. Sorry, suppose, okay, F2. Okay. So that means what? Where the F2 is present 1. When it is 1, when D4 is active. So here I am writing this is the D4. Again, what happened? This one is 1. When and 1 means what? Parallelly, which particular column is? This particular one means what? Which particular column? It is D5. So this one is D5. Next one is what? This one is D6. So this one is D6. And last one, D7 is active. So this one is. So F2, the output lines is the combination of the outputs will contain the binary code of the input lines. Okay. So that means what? D4, D5, D6, D7. And similarly, we can find out the F1. Similarly, we can find out the F0. Are you getting my point? Are you getting my point?
Yes, sir. Yes, sir.
So how next one, F1. And this is E7. Okay, so my diagram is not very good, so because I am using the mouse pad actually, so here's some particular problem. So you are getting this one based on the expression how you are designing the logic diagram for what for 3 into 8 into 3 encoder. So this one you are getting or not? Anyone is there?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so I'm not going some particular extra priority encoder is there. So I'll discuss tomorrow. Okay, next class. So I'm not because I'm not covering all the topics today itself. Okay. So now today we are discussing different type of things. We are discussing the how we are using the 16-bit error using the 4-bit error. Okay, and what is the time delay, CLA, and ripple carrier error. After that, we are discussing the what is the formula. Actually, we can find the time delay of CLA and the ripple carrier error. We are discussing also encoder, also decoder, also. Okay. So next class we can say that means one particular encoder is there that is called a priority encoder, and why this particular priority encoder concept is coming. Okay. And after that we are going some particular different combinations. Okay, thank you very much. Thank you.
Thank you, sir.
Thank you,
sir.
You leave one by one.
Yes, sir.